Hello everyone, and welcome to Fire Protection for the Airbus A320 family. This topic is broken up into 6 sessions. Session 1 is going to be an overview of fire protection. Session 2, extinguishing procedures. Session 3 is on panels, the fire panel and external power panel. Session 4, the fire bottles and the bottle tests. Session 5, fire and overheat detection, and our final session is on smoke detection. I want to start with a story, and you probably read some of this already, but there was an aircraft fire, American Airlines aircraft that was on the ground and had 151 passengers on board and 6 cabin crew, and someone had noticed flames, fire coming out of the back of the aircraft, and found out it was coming from the APU compartment. The department, this is in Seattle Tacoma International Airport, and the fire department of course came out and extinguished the fire. No one was injured in that particular instance, but just to give you an example of the danger of fire, there are internal, besides those that are in place, I'm talking about components that are in place to extinguish fire and detect them. There's also just an inherent protection from the design of the compartments where fire would be a great threat, fire or smoke. So kind of just giving you an overview on the different aspects or parts of the aircraft where we want to make sure that we don't have a fire or where it's more of a threat. It's going to be your engines, okay? Engines, your auxiliary power unit, the cargo compartment, and your avionics compartment, and then your lavatories. And your lavatories more from smoke. Okay, so we'll look at that smoke detection system when we get to the session 6. But that's your overview as far as the different areas where fire can be a threat. Your engines, your APU, cargo compartment, avionics compartment, and your lavatories. All right. Now, what kind of systems are there? What kind of elements do we have there on board to detect when a fire is starting or smoke? Okay. Also overheat. When there's temperatures get too high, that's certainly a potential for for something where fire can be, right? Because fire is extremely hot. Well, we have different things called detection loops. Those detection loops are they have 3 elements in them that are designed to, sense combustion gases. And then of course that gets sent, that triggers sending over a warning to computers. And I'm not talking in detail about computers right now, I'm just giving you an overview because this is going to cover whether we're talking about the fire detection system or even the smoke detection system, where we have computers that are there as the go-between or middleman, if you will, from the sensors sensing a danger level and then sending signals to the computer that send the information to the cockpit displays. So that's what we're looking at. All right. Now, just to describe a little about the detection of it, they're actually loops. And for example, we're going to talk about the engines and protecting the engine. There's going to be sensors around that area, like the turbine, for example, the turbine case, right? You're going to have it around there, and they're in pairs. Okay, so on that, the fire detection, we'll get more into detail with that. I'm kind of giving you a little bit more information right now in the overview, but those sensors are in loops, and they're in pairs around the engine area. All right, and again, like I said, they're there to detect fire. Usually they're temperature sensitive. The other thing too to be aware of is, the aircraft's designed pretty well. Certainly it's not perfect. We can't, there's things that we just can't help, but the way that they've engineered aircraft it's made it a lot safer for if there is a fire, that at least they can isolate the fire and not start you know, spreading to other parts of the aircraft, which of course is going to threaten the entire safety of the aircraft. So that's a good thing. But with the detection loops that you have there, you know, those are going to be they're set at certain thresholds so that when it does reach a certain temperature, it's going to trigger a warning, and then you're going to have all that going into the cockpit. And just different things, different aspects to the warning system in general is going to be chimes. Okay, you may have a repetitive chime, for example, and then you may have also red illumination of certain buttons. So you know, you'll have the chiming and flashing as well, so that the pilots will know, okay, something's wrong here. There's a fire. All right, detection of overheat. It's gonna be both overheat and fire. Is that you have these thermosensitive loops, okay, like I mentioned earlier, and those things are installed in the engine nacelle. Okay, and if you're into electrical concepts at all, it's an AND logic. I'm going to talk about the FDU, which is your fire detector unit, because the logic there is that both loops have to be operating in order to send that signal to the cockpit eventually. But here's the thing: they do work together. But if for some reason one of the loops is faulty, the remaining loop that's still working can actually still send a signal. So it's supposed to work together as in normal operation. Okay, that's the way it should be. That's why it's an AND logic. Okay, and then the smoke detectors. So we have fire detection. So these are the fire detection loops. And now when we talk about the smoke detection, these detectors are actually sensing combustion gases. All right, and it's very important to understand that the smoke detectors need to be clean because if you have contamination on the plates of these detectors, you're going to have, it's going to be very sensitive, and basically what's going to happen is going to start sensing smoke, you know, more smoke than there really is. You know, for instead of it waiting for that threshold, it's going to come prematurely, and then these horns are going to go off. So that's not good. We want to make sure there's no contamination from dirt or oil or, you know, whatever debris that might be on those plates that are part of the smoke detection detectors. Your avionics compartment, remember I mentioned that, that's a place where you have smoke detectors. Actually, you have one smoke detector there that's installed, and that's going to be installed where the air is vented out. And just so you know, there's a computer there. With the engine fire detection, we have the fire detection unit, which is an actual computer. Well, the same thing with the avionics compartment. And the avionics compartment, this computer is called the avionics equipment ventilation computer. If you ever see or get asked a question on a test, what does AEVC stand for? It stands for Avionics Equipment Ventilation Computer, AEVC. If you see in the test the abbreviation for something and you don't see it spelled out, do let us know, because one of the things that I like to do is spell it all out, because there's no need in memorizing things. Although if you've been around the industry a long time, you're used to saying McDo or FADEC or whatever. You're not spelling it all out. But I just want, for clarity, that you understand what the questions are. The cargo compartment. So I said avionics compartment. Now the cargo compartment has smoke detectors as well. Avionics compartment has 1. The cargo compartment has 6 smoke detectors. That might be a test question. Please take notes. Okay, so cargo compartment has smoke detectors there, and there are 6 of those. And what's the computer for that one? Okay, what's that one called? Okay, this is actually called the Smoke Detection Control Unit. Okay, it's abbreviated SDCU. And that's, again, the cargo compartment. You also have the smoke detection control units for the lavatories, because that's where you also have a smoke detector. And again, the computer, it goes through in order to send send those signals over to the cockpit displays. The ECAM in particular are going to be through the Smoke Detection Control Unit, your SDCU. All right, so I hope it's giving you a kind of fleshing out a little bit about the areas where we have the greatest threat. Okay, your engines, the APU, your auxiliary power unit, the cargo compartment, your avionics compartment, and you have your laboratories. Now, one of the things that we want to be aware of, I guess from a maintenance standpoint, is cleaning of components, right? Keeping components clean. Because remember I said earlier that you can have those plates dirty in the smoke detection the unit, and it can give a misread. Okay, so just things like that in case you're ever around that. The other thing too, well, I'm mentioning about cleanliness and being careful with that. The loops that are around the engine, because there's 3 places we're going to cover a little bit where all those are located. We're talking about the pairs of detection loops, fire detection loops. You want to be careful when you're handling, if you're having to remove them. They have a material in there, and you want to make sure you have your PPE and that you're not exposing your skin or your face or whatnot to those elements. I'm talking about the material that these loops have, okay, in them. So again, these things are very sensitive, and they do have, again, material that can be hazardous to humans. So please be careful when you're handling all that. Safety's the first and foremost important aspect to all of this, namely your safety. All right. All right, so that kind of gives you an idea, an overview of the different aspects of fire protection, meaning different areas where it's the greatest threat. And then there are detection loops, okay, that are there to protect or to contain the fire, to sense it. And then, of course, we're going to get into extinguishing here in a little bit. Okay, so that's kind of an overview. Of course, you have indications in the cockpit. You also have an external power panel that exists, and I'll get a little bit into that in a little bit, but just wanted to give you that as part of the overview, that you have the fire and APU panel, which is actually together in the cockpit. And then you also have your power panel, which is on the outside, and that actually has to do with your APU. So if there's an APU fire, the horn's going to go off at the external power panel. It's also called the service bay interphone panel. That's where that happens. All right, maybe I'll give you a few test questions right now, just an idea, because you may or may not see all of them. If I mention some now in class here in this instruction, if I mention them and I go through them, you may or may not see all of them. Sometimes I may not have covered some questions, and maybe you'll see it on the test. I try not to have that happen because you didn't even know which ones they were. But do listen to the material, because the questions are coming from the material that you're listening to. All right, so we're on session 1 on the overview. Let's just go over question number 1. Okay, it's kind of a review question, or what I call knowledge checks. So if you see that on the screen, knowledge checks, it's the same thing. Review questions, possibly a test question. What are all the threats related to the fire protection system? Okay. Well, there's 2 choices. Number 1, smoke, overheat, and fire. Or B, smoke and fire. Okay, it's the first answer. Smoke, overheat, and fire. Number 2, what are all the areas of major concern on the aircraft as it relates to fire protection? Okay, is it A, the pneumatic system, the cargo compartment, and the engines? Or is it B, the engines, the APU compartment, or the APU, the lavatories, and avionics compartment? You're right, it's B. Okay, remember also it includes cargo compartment. But just just when you read the question, just answer it as you see it. Number 3, what does AEVC stand for? Okay, choice A, avionics engine ventilation compartment, or B, avionics equipment ventilation computers. Okay, it's B. Okay, what does SDCU stand for? Okay, I mentioned that smoke detector, that there's smoke detection. Okay, it has its own computer. Okay, so that's called the smoke detection computer. Is it computer unit or control unit? It has its own computer, but it's not called computer unit. It's called control unit. So that's letter B. That's the second choice. What does FDU stand for? FDU, fire detection unit or fire display unit? It's fire detection unit. Okay, detection. Okay, that gives you an idea for session 1 and some of the questions that might be asked of you on the test. All right, let's go ahead and go into extinguishing procedures, and then we'll, proceed in covering some of the what we see on panels, or what's on the panels in the cockpit and also on the power panel. All right, on session 2, we're moving on to session 2 now. This is the extinguishing procedures. Now, on extinguishing procedures, you're going to see some similarity when we talk about the engine and APU, because remember, APU is also a little engine. It's the same, it's similar. And you have the fire bottles that are going to be obviously putting out the fire. But what's the first thing, how are we going to start this procedure? How are we going to start this process going with actually discharging the bottles? Well, that's going to be in the cockpit. Okay, in the cockpit, you're going to have, let's say there's an engine fire. Okay, the pilot may or may not know that. Then the control throttle lever needs to be in idle. The master control switch needs to be in the off position. And then the pilot is going to push that engine fire electrical push button. And then there's a countdown that occurs. Now he's not counting down. There's actually like a little clock on the display as it counts down. Okay, and after that happens, then there's going to be the pressing of the agent push switch. Okay, because we're now talking about the discharge of the agent, which is contained in the fire extinguishing bottles. Okay, so it's gonna do one at a time. So just one, for example, if the fire's not too bad, and the pilot, after he pushes the engine fire electrical push button and the countdown starts, and then he pushes the discharge push button, then the first extinguisher bottle is going to discharge. Okay, and that's going to show up as illuminated on the panel. Okay, now if for some reason the fire warning light doesn't go off, because the fire warning will be showing illuminated, if for some reason that first bottle didn't do the job and the fire is still being detected as existing, then the second bottle is going to be discharged. That's on engine fire. Now it's somewhat similar to same with the APU fire. Like, for example, if there is an APU fire, with here there's a button in the cockpit it's on the fire panel that says APU fire. So APU fire, there's a push button switch there. When that happens, the APU is going to shut down. What is the one thing you don't want to have near fire? Okay, there could be several different things we could probably name, but what one specific element that we definitely don't want to have? Can you think of it? I hope so. Okay, fuel, right? Because you don't want oil either, but fuel we want to just cut off the fuel. And that's what happens when the APU fire push button is pushed, then it's going to cut off the system. It's going to shut down the APU in this particular case. And also with engines, it's going to cut off the shutoff valve is going to close for fuel. With the APU, the bottle is going to be armed for the discharge. That's when the squib light comes on. There's a button that says squib on it. Okay, and squib, by the way, which is a test question, but I'm kind of jumping ahead a little bit. But since it's mentioned here, I'm going to go ahead and tell you what squib is, because the question is, what is a squib? Okay, not a squid and like a sea creature in the ocean, but what is a squib? Okay, if any of you are familiar with firearms, we talk about squibs too. It's you know, it's a little here in when we talk about as it relates to fire. Squib is it's a cartridge that has powder in it, explosive powder to be particular, and there's two filaments there that actually cause it to explode essentially, and anyway, that's what that is, and it allows that discharge to occur. So that white squib light that has the word squib on it is going to come on. Okay, and then like I said before, the APU fuel is gonna shut off, because we don't want to have fuel continuing to flow when there's a fire. And then of course the electrical generator basically going to shut down any electrical power or flow, any fuel flow we don't want to have flowing when we have a fire. Okay. With the extinguishing, once that procedure happens, there's going to be there's going to be that. Remember I said about the 10-second countdown? Same thing happens with the APU. There's a 10-second automatic countdown that occurs on the ECAM, and that's going to show like a counter on that ECAM. And that is just going to allow time for the airflow to decrease inside the APU compartment. In the engine, incidentally, we would talk about engines. For example, if they have engine fire push buttons pushed, there's that 10-second delay. Now, why is that? Why is there a 10? I mean, you think, gosh, what an emergency. Why would there need, why does it have to be an automatic, 10-second delay from discharging the extinguishing bottles? I mean, do you have any idea? Because you might find that a little counterintuitive. Like, well, that's curious. I mean, don't we want to hurry up and get this thing put the fire out? But that 10 seconds allows, on the engine side, allows the engines to kind of spool down so that it can actually maximize the extinguishing power. And likewise with the APU, instead of spooling down the engines, this is an automatic APU shutdown, but it's allowing the airflow to literally be cut off, or be cut off and just allow it to be decreased in the APU compartment, because again, we don't want to have that environment or ambiance when we have an APU fire. Okay, and again, likewise with engine fire, we allow the engines to kind of spool down some so we can have that maximization of putting out the fire. Now, what about a fire in the cargo compartment? What about that? Here you do have an extinguishing system, and it's just a single shot type of deal. You've got the bottle, you have discharge lines as well. Of course, you're going to have a display. You can have the push button switches that will start the whole thing. The indication lights that you're going to have, or like I said, the display is going to be smoke/DISCH for discharge, right? And then you have the smoke control unit. Remember I said about smoke detection control unit, SDCU. That is part of it. Okay, that includes that SDCU, because what's it going to do? Remember I said the computer's the middleman. It goes between the sensor sensing when there's fire or smoke, and it reaches that threshold and says, okay, it's triggered now. Then it's going to send those signals to that computer. Well, if there's a cargo compartment fire, it's going to go through the SDCU, okay, that smoke detection control unit. And then of course from there it's sending signals to the ECAM. Okay, and also for maintenance purposes, you're going to get data on the ECAM in the cockpit. Okay, now where do we have, since I'm on the cargo compartment fire thing, it's the forward cargo compartment has the extinguishing bottle, incidentally. Okay, all right, I hope that gives you an idea on extinguishing. Extinguishing, there's an engine fire. For engine fire, you can have engine fire push button. For APU fire, you're going to have a button called APU fire. And with the cargo compartment fire, you have a display on there that says smoke /DISCH that'll illuminate on there. Okay. All right. That's your extinguishing. Let me go ahead and throw a couple of knowledge checks and give you an idea what kind of questions you probably will see as it relates to our session 2 on extinguishing procedures. And just I hope you're following along in your handout instead of just listening. Number 9, when executing the steps to put out an engine fire, how come, why must the pilot wait 10 seconds after pushing the engine fire push button before pushing the agent push button switch? All right, he's doing the engine fire one, and then there's a countdown. Remember I said on the ECAM there's a countdown going on? Okay, here are your 2 choices. Number 1, to give the pilot a chance to mentally collect himself in a crisis situation. Or is it B, to allow the engines to spool down so that deployment of the extinguishing agent is maximized? Okay, it's B. All right, let's hope the pilot's already been trained to deal with crisis situations. He doesn't need to mentally collect so much. Okay, number 10, what's the one fluid that must be cut off to the engines immediately after fire is detected? Is it fuel or oil? Okay, it's the one that we mentioned, and it was fuel. There's other elements too we don't want near fire, but we certainly don't want fuel. Number 11, when the pilot pushes the APU fire push button switch, the white squib light comes on. Is that true or false? Okay, that's true. And incidentally, there are true-false questions on this test besides multiple choice. Question number 12, regarding extinguishing of a fire in the aft cargo compartment, the system includes the SDCU, which is the smoke detection computer unit. Okay, what does this do? Okay, does it, let's say choice 1, does it send signals, or does it send this message to the ECAM, or does it send message to the cockpit display to let the pilot know what's going on? Or does it send an oral warning? Okay, it's A. The signals that are going there, and when it sends signals to the ECAM, it is going to trigger horns. It could be things like that. But specifically, we're talking about giving the data, okay, the fire data or the smoke data of that there is, an actual fire or smoke. Okay, but just keep in mind, smoke detection computer unit or control unit, excuse me, is just a go-between. Remember, like a middleman. Okay, let's go ahead and explore a little bit more. I know I mentioned some things on the fire panel, and it's like the fire and the APU panel, but I do want to go into session 3 and talk about the external, or introduce to you the external power panel, and also maybe some indications and control. Okay, let's look at this a little bit. Again, I covered already some engine and the APU fire panel. We know that on here, once we have the engine fire push button switch turned on, that we're going to have the cutoff of fuel, and the hydraulic shutoff valve is going to be closed. Your IDG is going to be de-energized as well. The closing of bleed air. Okay, we don't want to have that going through either. Okay, and there's going to be, of course, the arming of the fire bottles. That's going to happen. All right. And I do want to talk a little bit about the discharge switches. Those are right next to the engine fire. Remember I said engine fire will be first, and then there's the countdown, and then there's the pushing of the agent discharge button. There are 2 agent discharge buttons per engine fire button. Why? Because there's 2 fire extinguishing bottles per engine. And then you're going to have the indication of squib and discharge. Okay, the squib light's going to light up. Remember I said that before, it's going to light up in a white illumination when that fire push button is activated. And then if the discharge is the DISCH, okay, if that is lit up, then that actually means that the bottle pressure is low. The pressures in the fire bottles are important. So there could be faulty bottles. Those need to be tested for sure, because pilots relying on that to function properly and be at the right pressure. And there's different aspects or little characteristics to these fire bottles as far as pressure. There's a range there to ensure that they are pressurized correctly. Your external power panel, remember I mentioned that this is part of session 3. External power panel is the same thing as your service bay interphone panel. And here is where you can have that horn go off there if there's an APU. And this is, remember, this aircraft on the ground, and let's just say there's an APU fire like I just described starting out this lesson. American Airlines craft on ground. Somebody notices fire coming out the tail end of the aircraft. Coming from the APU compartment. Then there's going to be a horn sounding at the interphone panel. All right. Okay. Let's probably go a little bit more into the indications. Okay, I'll cover that here, and we'll see what a little more we can get out of this. Let me go into power panel, then we'll go into indications and control. The power panel, just a few items here I want to highlight. On here, remember I said that there's going to be a warning horn that's going to go off, and then there's also the APU light that's going to illuminate, and it's going to be in red. Now, the horn can be really annoying. Like, okay, you already know that there's a fire. The horn, obviously, once the fire is extinguished, the horn is going to stop sounding. If you didn't want to wait till then, if somebody wants to turn the horn off, they can do that from the flight deck or from the service bay interphone kit panel. The flight deck, if you're inside the cockpit or pilot is, they can actually turn that off by releasing the APU fire push button, or if they press the guarded APU button. Okay, that's on the outside, so maintenance or some other personnel can actually push the guarded APU fire button, and that'll stop the horn from making noise. Okay, so that's what you have at the power panel. All right, now indications is what you have there, and then that's pretty much what we have on session 3 on the panels. The indications and control, that's indications at the interphone panel. Let's go ahead and move on to session 4. Session 4 is on the actual fire bottles and bottle tests. Remember what I said, the importance of pressurization, because it has to move that agent, okay, that material that's inside that bottle. By the way, the type of bottles these are halon. Halon's a gas, by the way, in case you didn't know. That's on the periodic table of elements. But halon is an actual gas that's used, and that's the type of extinguishing bottle that we have. It has to be under a certain pressure. So let's go ahead and take a look at this, and then see what this is all about, and look at the characteristics of these fire bottles. First of all, just kind of describing a little bit about the bottles themselves. They are not light. Okay, I know it can sound silly, but that's actually a test question. They're not light. When you think about, I think, when I've done these oxygen lessons before, we talk about oxygen in the cabin and also in the cockpit. They're small, right? The individual oxygen bottles, for example, if there's a depressurization of the aircraft, there's an emergency, masts are automatically dropped down. Those oxygen bottles are, they're portable. These bottles, however, the ones I'm talking about right now for extinguishing engine fire are not so small. They're 380 cubic inches roughly in volume. They're halon type, and their pressure is 600 pounds of pressure. That's a lot. I tend to sometimes make reference to firearms, since that's what I'm familiar with for many, many years. When you talk about pressure, trigger, and pounds of pressure that's necessary to press a trigger on a firearm. Here, in these bottles, it's 600 pounds of pressure, okay, for discharge. The discharge time is less than 1.5 seconds. That's fast. And it's in a steel container. It's a spherical type of bottle. You have a safety pressure relief at roughly between 1600 and 1800 psi. There's a cartridge ignition, nominal current at 5 amps. Okay, I'm just giving you your technical specs for the engine fire bottles. Just wanted to get some familiarity about what they are. But anyway, that's just giving you a little bit. There's a few other things too, but the main thing is that they're spherical. They're not light. They're a halon type. The pressure, we're talking about pressure of 600 pounds. Your safety pressure relief, 1600 to 1800 psi. Okay, and there's also a frangible disc as part of the steel container. It has the outlet port with that disc that I just described to you. Usually they're a green color, but just pay attention, or have that awareness that there's a frangible disc there. Okay, the pressure test, there's a bottle pressure test with these, and there's a pressure switch as part of the bottle, and that pressure switch can be tested manually. Okay, it's calibrated when there's a pressure increase when you're refilling it, and then when the pressure decreases when there's a discharge or there's a leak. So that's one of the importance. We're talking about maintenance, obviously your maintenance personnel, but there's guys who are experts at knowing those fire extinguishing bottles and how to maintain them. I'm not saying that you would be one designated to do that, because you have other tasks that are given to you, and there's a whole group of companies that deal strictly with the fire extinguishing material, and it's the containers, obviously the bottles. So I just say that because it's like a special area of maintenance of these, but at least you have an awareness of what to look at and what to look for if you happen to be working somewhere near those bottles. Maybe something doesn't look right. You can at least notify your supervisor about that, and maybe there's something wrong. Okay, but just to let you know, those things have a pressure switch on them, testing for too much pressure, or maybe there's a leak and there's a decrease of pressure in that bottle. By the way, I know some of you work 2x2, and in some cases it's not possible, it's not feasible, because the staff, maybe lack of enough staff. But I know that a lot of you have worked with somebody else when you're going to change a tire or whatever on the aircraft. There's 2 of you. And the reason I'm saying that is because when we're talking about the bottle test, it requires 2 people. Because it just the nature of what you have to do to test it. You've got one to turn the wrench, okay, and then there's another in the cockpit to verify what's happening on the display, right, on the panels. Okay. Now remember I said, okay, what is a squib? And I already described it to you. I'm going to get a little bit more detail on the squib, just so that you have even more familiarity. What is a squib? Okay, and that's not a squid. We're not talking about a sea creature. We're talking about a squib. Remember I said it was like it's just a little explosion. It's a little cartridge that has 2 filaments in it that actually cause an electrical, when there's electrical current running through that, it causes the filaments to cause the powder to essentially ignite, causing a little explosion. And that's what that's doing. So that's what you have there. Also, even though there's 2 filaments there, you can supply power to one of them, And the one filament actually can suffice, okay, in case the other one isn't working. Okay, so, and there's a test push button for that if you're doing maintenance on that whole system with the bottle test. There's a test push button switch that is pressed. Okay. Of course, you're looking for the squib light, right? And also the disc, which is the DISCH legend on there. Okay. All right. All right, what else do we have on here? Just kind of cover here. All right, that's what you have. And besides APU, of course you have one for the APU besides your engines. And then you also have a waste bin fire bottle. I don't want to get into detail on that. So basically I just described to you what the bottles are like and the bottle test, you know, that you would do if you're assigned to do that. Okay, so let's go over some test questions just a little bit. All right, so what do we have here? Won't make it too long here. All right, let's go to number 18. So just follow in your handout. I'm on number 18. Okay, what is one characteristic of the fire bottles? Is it option A, they are very light to carry, or B, has a safety pressure relief at 1600 to 1800 psi? Okay, so the second answer. Okay, number 19, what is a squib? Is it A, an electropyrotechnic cartridge with 2 filaments, which causes an explosion when electrical current is present? Or is it 2, it's an electropyrotechnic safety valve which opens when electrical current is present? Okay, I just said what it was. It's letter A, the first answer. All right, let's go ahead and move on to session 5. This is fire and overheat detection. And with fire and overheat detection, we're going to be talking about the loops. I mentioned that in the overview just briefly, but these detection loops are in various places around the engine. Obviously, they want to be close to where fire could start, which would be near the engines, of course in the APU as well. Also overheat. These sensors, or the detection loops, are also designed so that if the temperature rises too high, okay, at a certain level, then it's already it knows that, okay, there's something, you know, that's usually where there's fire, is the temperature being at a certain level, so certain degrees. All right, on session 5 on fire and overheat of the engines, let's start with, let's just look at the locations, and we'll talk about the fire detection unit. Remember, FDU stands for fire detection unit. Again, you don't have to memorize all these because I'm going to spell them out on the test questions, or if you see it on a handout, you know, I may spell it out once and then put in parentheses the abbreviation. After that I may not spell it out, but at least at one point, you know, I would have done so. So let me know if somehow that, you know, you didn't see that somewhere, and we can get that solved. All right, let's look at the locations and see what we have here. All right, with the engine detector locations, these are in pairs, by the way. There are 6 of them, but they're in pairs. And you're going to find the detector elements are going to be around the turbine case. Okay, that's one area. And this may be a test question, okay, but just kind of take notes and just know where these are. One of them is going to be the turbine case at the rear part of the core compartment, and then you're going to have also the fan compartment that's close to the accessory gearbox. You're going to have a pair there. And then you also have another that's installed at the engine to pylon forward mount. So those are your areas where you're going to see those detection loops. Remember, they're in pairs. And each loop has 3 elements in it, because it's designed to detect a certain temperature, different temperature conditions. They're in the loops A or B, so you have, you know, these elements are in parallel to make up the one loop or B. All right. Also, when it comes to part numbers, you might think, oh well, you know, I have 6 detector loops. They're all going to be the same part number. Well, no, they're not. Okay, this is one highlight you can put in your notebook. They are not all the same. They might physically or visually look the same, but there are 3 different part numbers that we're talking about here for the engine detector elements. Okay, and the reason why is because it's not just detecting one temperature, it's almost like taking an average, because each of them is preset to detect or to sense when the temperature reaches a certain degrees. And they're all 3 different. So there you go, they're each unique, therefore they each have to have their own part number. Okay, I hope that makes sense. Okay, now the detectors that are near the pylon, remember I said there's the one the pair that's installed at the end of the pylon, forward mount, those detectors there are shorter, and just so you know, short is relative. I mean, what the heck does that mean? These loops, okay, or detectors are over 10 feet long. That's not short. Again, it's relative. You know, you men are what, like 6 feet, something like that. I mean, vary from 5 foot whatever to 6 feet. These things, you know, these loops are longer than that. They're 10 feet, over 10 feet long, and they rotate because you know how big you know these engines are, and you've got the turbine case. These are big, and they're looped around there. So anyway, pretty awesome. The fan, you have the fan loops are routed around the gearbox area, and they're routed from the engine oil tank on the left all the way to the IDG area, okay, which is on the right side. So from left to right, you've got around the oil tank, and then it's going to the area where the IDG is. So I hope that gives you an idea there. And just so you know, with the loops, remember they have the elements in there, 3 different part numbers. Why? Because all 3 different elements are unique, because each of them are calibrated for picking up a certain temperature, and each of those elements are set at all 3 different, you know, 2 different temperatures, or, you know, degree of sensing. The fire detection unit, which is part of all of this, is 2 channels. Okay, it's a computer, but it has 2 channels. Okay, channel A and channel B. Your primary channel is going to be your channel A, just like when we talked about other topics. When we talk about the computer system and it having an A and B channel, channel A is always considered the primary channel. Same thing here. It's not different. Here, your channel A is the one that powers your byte. Okay, it's going to send the fault information to your centralized fault display interface unit. Okay, so you have that. With normal conditions, each of the channel monitors its own loops, but it can operate also when one is not working. It can actually help monitor the other as well. But again, I was just talking about normal conditions. You know, each channel is responsible for monitoring its own self. And then just a little on the logic. This is when we talk about not just computer logic, but computer logic. The fire detection unit. Okay, so you have fire warning signals that are being sent from the FDU, and it's going to do that if you have conditions that are present. For example, remember I said this is a dual channel, so you have A and B. You have fire A and fire B. Okay, those are the 2 loops. It has those 2, then it's going to be sending that data to the cockpit. If you have a fire A and a fault B, that's another condition. It can do that. Of course, if you have a fault A, fire B, okay, so just swapping that. And then if you have a fault A and fault B within 5 seconds of each other, it can also be that condition where you're going to have the fire warning signals that are issued from the FDU, your fire detection unit. Your fail messages, so if you're doing maintenance and you find fault messages, what you're going to find with loop failures, the reason why you're going to have a loop failure is going to be electrical. That's one thing. Okay, so that's one electrical failure. There's a failure of somewhere in the circuit. So the detection circuit, somewhere there's a problem. There's a fault in the detector itself. Okay, So something with that, not just in the entire circuit. Detection of a single loop fire, if it's longer than 16 seconds. If the other one's in normal condition. So if the other one's in normal condition and then the other one is, there's a fault going on, some fire, something going on with that that's lasting longer than the 16 seconds, then you're going to have a failure message. Loop failures, just so you know how there's class 1, class 2, class 3. Your single loop failure warnings are displayed on the ECAM as a class 1. Now there's also levels within the classes. In this particular case, when we're talking about loop failures, this one happens to be a class 1, level 1. Okay, and that's when you have just one of the loops failing. Now, what if both of them fail? Both of them are shown to not be working. Okay, then you're still going to be a class 1, but now we've increased it to a level 2. All right. Okay, so just so you know, all that information from the FDU is going to be sent to where? It's going to be sending the information to the ECAM. It's all actually going to be reported to the Centralized Fault Display Interface Unit. Okay, your CFDIU. All right. Didn't mean to overload you there, but I know that's a lot of information, but it just to reiterate, because I mean, just know that you're going to have fault messages from your loops, and the way they show up on the ECAM is going to be they're both class 1. If the single loop or both loops are failing, they're both a class 1, but you'll have a class 1 level 1 with a single loop failure and a class 1 level 2 if both loops fail. All right. Let's look at a few test questions. I don't want to inundate you with too many, because with all the different sessions that there are for for most of these topics, now we're talking a lot of questions. I just want to make sure I guess if it were really truly, if I really wanted to have my druthers, I'd really test you, because I want to go into such detail, but we'd be here forever. But that'd be another class if you're later on, if you wanted to study something more in depth. We are more than happy to make that happen. All right, question 20 on your handout. This is under session 5, fire and overheat detection. Okay, where is one area that the engine fire detectors are located? Okay, option A, installed at the engine to pylon forward mount, or option B, inside the accessory gearbox. You're right, it's installed at the engine to pylon forward mount. All right, question number 21. The fire detection unit, also abbreviated FDU, is a single channel computer. Is that true or false? That's false. Remember I said that it's a dual, it has channel A and B, channels A and B. All right, question number 22. How long are these detector loops? Roughly. Okay, your choice A, 10 feet long or 20 feet long. Okay, it's closer to 10, I would say 10 feet. If it's over 10 feet, it's still closer to 10 feet than it would be 20 feet long, at least in the A320. All right, question number 23. How many different part numbers are there? It's very important. How many different part numbers are there for the engine fire detector elements? Is it option A, 2, or option B, 3? Okay, it's 3. Remember I said there were 3 different part numbers. Why? Because there's 3 different elements per loop, and each of those elements is rated, or calibrated to sense a certain temperature, and each of those, for each of those, it's 3 different temperatures, 3 different degrees that it's calibrated to. Right? All right, this completes session 5. We're on now to our last session, and then we'll close up here. Session 6 is on smoke detection. fire is bad enough. Smoke's not good either. Rick actually had, at first time, you know, it's funny, you never, there's a phrase or a saying that says you're never safe from surprise until you're dead. And then some people, well, you live long enough, you know, you've seen it all type of thing. But you know what? You know, after Rick's been flying for over 30, well, like 31 years now, there's, even recently he came across something he had never come across before. That's another story. That was when both generators like went kaput. But then he had, at one point, he did have smoke in the cockpit. And he will be sharing that story because that's, you know, personal testimony, besides just saying, okay, there's a story out there that's printed out there from ABC or whatever news story and news station, right? Smoke is very dangerous. You inhale smoke, you die, you know, if you're in it long enough. So it's very important. Plus, you know, where there's smoke, there's not necessarily fire, but besides the inhalation, it can cause damage to property. Not only that, it can actually, you know, cause malfunctions of other equipment that, you know, can lead to a fire. So again, you want to treat it just as seriously as a fire when you have that. Let's go ahead and look at smoke detection. And where do we have smoke detectors? Okay, that's the question. You know, where do we have the smoke detectors? I mentioned that in the overview, but we're getting now into detail of where do we have them. Smoke detectors, okay, write this down. Smoke detectors are found in the cargo compartment. There are 6 of them in the cargo compartment. You have 1 in the avionics compartment, and then you have 1 in each of the lavatories on board the aircraft. Okay, so let's kind of just get a broad stroke with the smoke detectors in general, and then kind of go into, you know, the smoke detector systems as it relates to each of the compartments or areas where they're located. All right, so let's look at this. Okay, smoke, you know, just in general, and detecting it. And just, yeah, let's just go on this. And remember that I'm going to come back to this abbreviation, the AEVC, because avionics, that's where we have a smoke detector. But smoke detectors, the way that these are designed, I mean, they're designed like you would find something similarly, at least in a house, or, but just a way that it's sensing. Okay, it uses an ionization chamber to sense gases, and if it reaches a certain level or exposure to that gas, then it's going to trigger an alarm. And that's how it works. And the way this internally, you know, is composed is you have electrodes in there, okay, and also in these chambers you have a radioactive material that's used to ionize the air particles in there that are going through the electrodes. There's 2 electrodes in there, and when they're going through there, then you have that radioactive material that's ionizing those particles. With that, then you have a voltage that's placed on the electrodes, and then you got current going through there. Okay, so let's say you got smoke. Okay, now as smoke is not it's not a good conductor, okay, of the ionic current as the way that air is. So it's causing a resistance to that, and that's part of how it works. It's creating that resistance because it doesn't have that conductivity the way that air does. Anyway, that's, you want to know more about that, it's a whole another topic. And the idea here, I'm just kind of giving you a familiarization because, you know, again, that's a whole class on, oh, how does a smoke detector work, you know, and get all the physics into it. With maintenance, you know, you're concerned with, you know, is it working or not? And is there an indication, you know, a fault message that says, hey, we got a smoke detection problem. It's not working and we got to get it to work again. So with here, one of the problems that you have with smoke detectors not working is that you can have dirt and oil and moisture is the worst. I say if you have planes that are going to the Grand Caymans, or, you know, these places that are very humid in the air, if you have that humidity, all that moisture, it can affect the actual smoke detectors. And all of that moisture being collected inside the chambers, remember I said about all that, collects on the plates, okay, because you have the electrodes that are there, right? All that is actually increasing the resistance in that chamber. Okay, so what happens? What happens when you have that more of a resistance in there? Well, now the smoke detector is becoming more sensitive, and it's not going to not going to require as much smoke now for it to say, hey, there's enough smoke. You know, then what's going to happen? These things are going to start going off when they shouldn't. So that's kind of the problem with that that you have. And again, you have to remember laboratory, that can happen because you have smoke detectors in the laboratories, and a lot of moisture can certainly collect in these areas. So just something to be aware of, just to have the knowledge. Not only moisture, because you have moisture, you know, contamination in those in the chamber of the actual smoke detector, but you can also have the problem with the detectors in the cargo compartment, and this would be in particular when you have extreme cold weather. So again, when you have extremes of too much moisture in the air, or there's extreme cold weather, you know, there could be some problems with the smoke detectors. All right. Now, what about the smoke detector in the avionics compartment? Okay, remember AEVC? And I said, you know, and the reason I'm testing you sometimes on the abbreviation is just to help you verbalize and write it down. This is what it is. You know, it's not a test of it would be able to memorize it when you're at the aircraft. Well, who really cares? I mean, you know, main thing is, you know where to go, you know where it's located, and you know you're you know, addressing the right piece of equipment. Your AEVC, okay, that's your avionics equipment ventilation computer, is going to be monitoring the cooling system. Remember, in avionics, the avionics compartment creates a lot of heat because that's where you have all your electronics, right? So you know, a lot of it's running off these, it's constantly running. And every time you have that, of course, you're creating heat as a byproduct. There has to be cooling fans and just, you know, just some kind of circulation for that area. And that's what, you know, here we want to make sure we don't have a buildup of heat, because, you know, we could have something smoldering. It's kind of like having a bunch of dry leaves and it's really hot, and if something, you know, the sun's beating down, you know, something, right? You know how when you have a bunch of leaves, so you know, you could have actually something start, you can start smoke, you know, start a little fire. This here is the smoke detection system is monitoring that cooling system in case there's smoke that starts to form. And the detector is actually located at the duct, okay, the extraction duct of the cooling system. That's upstream of the extract fan. Remember, there has to be a, remember I said there has to be a cooling system in the avionics compartment, and there's a fan there as part of that cooling system. So what happens? You know, what happens if there's smoke detected in the avionics compartment? Okay, well, if that's going to happen, you know, if there is smoke detected, that's going to indicate that there's smoke being produced by the equipment, you know, obviously in the avionics area, and it's going to be going through the SDCU, okay, your smoke detection control unit, to give those messages to the cabin crew, right, in the cockpit. Okay, those will show up there on the MICDU. Now, just so you know, the same type of unit and is actually located in the cargo compartment as the avionics. I will warn you right now, do pay attention to part numbers, because just because one looks like the other, okay, and I'm not saying they're interchangeable or that they're not interchangeable. I'm just letting you know that it's called the smoke detector control unit for the cargo compartment as well as the avionics compartment. Do make sure you pay attention to part numbers when you're doing replacement, just okay, to let you know that. There are there's a total of 6 detectors in the cargo compartment. Okay, there's 4 that are installed in the aft cargo bin, and then there's 2 in the forward. So 4 in the aft, 2 in the forward, and they're in pairs normally. Okay, And again, same procedure. It's going to be detecting the smoke, and then that information is going to be picked up by the control unit. That's going to give alarms to the aircraft warning systems. Okay, remember also all of this information and data is going to the fault display because, you know, obviously it's a way to identify where those faults are located, right? All right, and then cockpit indications, and then we'll be done here. In normal operation, when you have smoke detected in the cargo compartment, as an example, on the cockpit or in the cockpit, you're going to have the actual warning light, forward or aft smoke. Okay, that's the way it's written on the panel for warning light. Is aft smoke, forward, forward or aft smoke. Your master warning push button is going to flash in red when that happens. There's also going to be a repetitive chime sound that comes on, and then there's going to be on the upper ECAM display unit, and just this goes for any other smoke detection system, whether it's in laboratory or the avionics compartment or cargo, it's going to be in the upper ECAM display unit. So upper display unit of the ECAM, that's where you're going to find the smoke warning indication. All right. Okay, let's just going to go into a few questions for session 6. Where are all the smoke detectors located? Okay, here are your two choices. Choice A, avionics compartment, comma, cargo compartment, comma, and lavatories. Or option B, accessory gearbox, comma, nacelle, comma, and avionics compartment. It's going to be option A. Question number 25, on what display does the smoke warning indication show? Option A, upper part of the ECAM, or B, fire detection unit. Okay, it's A, remember I said upper part of the ECAM. All right. Yeah. I mentioned about fire extinguishing procedures, remember I said for the engine, the APU, and also for your cargo. Cargo has a single shot fire extinguishing. Okay, so we have that. I just want to kind of do a summary, just a quick brush stroke again, so you remember little bits and pieces again. And then if you have any questions, of course, email us and let us know what's on your mind as far as all that. But remember, session was an overview about where are the greatest areas of threat of fire. Okay, that's going to be your engines, your APU, your avionics compartment, your cargo compartment, and lavatory, because not just fire, but threats of fire and smoke or overheat. And then what do we have in place physically to detect fire or smoke or overheat? Okay, we have detection loops that are located around the engine, right, and then around the turbine case, and then installed at the engine to pylon forward mount, the fan compartment. So just areas like that, and then also, of course, in the areas I mentioned earlier. Okay, cargo compartment, your avionics, lavatory. So, and then extinguishing procedures, the push buttons on the fire panel. This is your fire and APU panel specifically. That for every engine fire push button, you have 2 agent push button switches. Why? Because we have 2 fire bottles per engine. And with the APU, we have 1 fire extinguishing bottle. Now, the tests that we have for bottle, what are we testing for? We could have a leak, or we could have an overpressure or something that's increasing. We have increase in pressure. We don't want that either. We don't want to have too much pressure or too little. If it's starting to decrease, there probably is a leak, so that needs to be checked out. Okay, and then of course your panels, your external power panel that you have for APU fire is going to be there on the external or outside part. It's not plain on ground. And your indications, of course, I mentioned before, indications and control. of how to cancel out some of the horn, right? Cancel out the chimes and whatnot. And then of course you have smoke detection systems in different places. We covered that in session 6. So that pretty much concludes our whole topic on fire protection on the aircraft for the Airbus A320. If you have any additional questions in your mind, or you didn't understand the part of it, or you want to get into more detail, because we love getting into detail. We just know this is the familiarity, and we know that you've been in the industry for quite a while, but there are areas where I know for a fact you've never worked on before. So please, ask questions, and we look forward to having you. Thank you for participating here. We definitely look forward to teaching more material to you in the other lessons.